Okay, cool. Well, there we go. It's all done. You've had the title. I'm Steve Poole. Speak into the microphone.
Olimpiu Bob, nice to see you.
Okay, so we have we're going to do two parts, and I will probably end up interrupting and talking about stuff. But this topic it's important. We want to introduce you to something new that's coming down the pipe from the powers that be, and we want to talk a little about why it's necessary, and then we'll have a conversation about where it's going, and if any of you are interested, you can ask questions, and we'll keep it as lively as possible. Okay, so that's interesting. Why did that come out? Okay, so that's us. So I work for Sonatype. Olimpiu doesn't work for Sonatype. I developer advocate, and I care about Java security and supply chain, so you can see where I'm here. Let's start with us. How many people here have downloaded code from Maven Central? Of course. Hey, did you know that Sonatype, we run Maven Central for you? Maybe you did, maybe you didn't. The fact is that you download code from the internet, because you go looking for something, you Google for it, or you go to Maven repos or whatever, and you search it, and when you're finished, you've got this thing. You've got some dependency thing to paste into your POM, and you do that, and you move on. That's what it's about. And even if it's not Maven, even if it's one of the other famous Java build systems, of which there are probably more than you realize, there are a lot out there. It's the same thing. You consume open source code, and you just do it by putting a dependency into your POM. The interesting thing is that almost all of your application is in fact somebody else's code. Because when you look at the amount of code that you consume as dependencies versus the code that you actually write, on many, many instances, the open source code far outweighs what you write. Sometimes the numbers are different, but it's usually this sort of number. So our applications live or die off dependency management and repositories, right? And you may not even have thought about it. You just go through this process of specifying something in Google, finding some coordinates, put it in, you're done, right? You might have some commercial software that might have a say in the matter, but that's basically what it is. You go through these processes. And then you just build it, and you do Maven compile or whatever it is, and a whole bunch of stuff downloads, and you're done. Now, the interesting thing, since it mostly comes from Maven Central, is how much of this is going on. 496 billion requests in 2021 to Maven Central for binaries. That's how much is out there. That's how much people are consuming it. It's a big number, right? Thing is, we're not very good at understanding what we download. As developers, we tend to do that first thing, unless the business software supply manager gets in the way, you download something and you don't even think about the other downloads that come with it. I'm going to ask you this. Of those of you who have put a dependency into your POM, how many of you have checked the license of that dependency? And you're all going, no, not me. I don't know what that means, right? And if you think about it, even if you had checked the license, you probably wouldn't have checked the dependency of the dependency, or the dependency of the dependency of the dependency, and yet you pull it down, right? We're not very good at this. We really hardly pay notice to what's in there. Hence, things like this. Who's heard of Log4j? Who had a good Christmas because of Log4j on the 9th of December? Yes. Log4j is the worst vulnerability possibly ever, but definitely ever in the Java space. And though you can see that the downloads, these are downloads from Maven Central since whatever it was, 9th or 10th of December. All right. Some important numbers to bring up for you. So that's the first one, is the number of downloads since we started, 51 million. The 33%, right, vulnerable downloads in the last 24 hours. 33% of the code that you, as developers, are downloading, sorry, Log4j that you're downloading, is the wrong version. Because you didn't check. You just assumed that somebody would fix this problem and you just downloaded it, right? So where are we when we have a situation with the most important vulnerability in the Java space? A third of us are still using vulnerable versions. All right, so it gives you 3 reasons you can think of where we might be doing, that may be the reason. Number 1 is the scanning tools that you're relying on, which are probably not run by you as developers, but is run by you at your business. The ones that are the commercial ones, they aren't not being used. Okay, maybe you haven't got any. Maybe you're relying on things like Dependabot. So maybe your scanning tools aren't very good, but you wouldn't notice because you don't even know that you've downloaded it in the first place. So you as a developer are culpable because you don't realize what you've consumed, and your business is culpable because they're using the wrong sets of tools. And neither of you speak. You don't talk to the IT guys and say, hey, we've downloaded the wrong version of Log4j, because you don't check, right? So somebody doesn't care or understand, hence we have this. And this is just one. This is happening all the time, right? Okay. So the thing is, when you're scanning this stuff, you have to ask yourself how it works. So the obvious thing is, if you have a POM file, you have some dependencies, and it tells you name, address, version, date of birth. And your scanning tools can look at that and go, I know exactly what it is. I've got the vulnerability data, easy. If it can't do that, it's not a scanning tool. Then there's the dependencies of your dependencies. Some scanning tools can't even do this. But you may not realize that because nobody in your organization has tested to see what these things can do. So some of the scanning tools aren't very good. Right? And then there's another thing. Oh, well, they're not meant to be yellow boxes. They're meant to be red and green boxes. But even within this idea of can you scan through dependencies, the bad guys, and we'll talk about those in a sec, and maybe not just bad guys, just us don't really understand, we do things like create fat jars, and we hide all the metadata. So your scanning tools have to be able to look at the binaries that you've consumed and work out what you've downloaded, because it may not be obvious. Not many scanning tools can do that. Right? And then there's an even worse situation where somebody's pulled out, and this happened in Log4j, the JNDI class, which was part of the Log4j, basically the thing most likely to cause the vulnerability. People were pulling it out and using it for different functionality. So again, you need scanning tools that can keep track of this stuff happening. So what we've got here is a situation where we're looking at what we've installed to figure out what we've got. Bear that in mind, okay? So currently, we know that the scanning tools that people use aren't good enough for many reasons. And they're unless you understand exactly what that scanning tool can do, you may miss the fact, or it may miss the fact that you have a vulnerability. Unless you have testing tools in place, testing for the scanner to do its job, right? So every time that you miss one of those, it's a vector for the bad guys to get their malware in, okay? And it doesn't actually, scanning of binaries and things like that is interesting, it's important, but it's not the only vector, and there are other vectors for how vulnerabilities get into your system, right? So I want you to leave right now, so just think about this. We're talking about the scanning tools that we use are sort of reactive. They analyze what you've got to their best ability, and depending on how good the scanning tools are, they may not be able to figure out what it is that you've got installed. And that's a key point of what we're going to talk about. Okay. So now let's talk about the bad guys, because you need to understand scope the scale of what's going on here. Because we talk about log4j and 33% are poor versions, and you might go, I don't care. Why is that important? Why is that a problem, right? So, first things. Bad guys mostly are not 15-year-olds in their bedroom hacking traffic signs. They do exist, but it's not really what they do, right? They are much more professional. They are much more motivated, right? They know exactly what they're doing. So let's put some numbers up. 2016, seems a long time ago now, 2016 was the turning point where the value of cybercrime exceeded the value of the illicit drug trade. So you think of all the movies that you've seen where people burying money in containers or speedboats, all those movies, and that was for the drug trade, and that was 450 billion, and cybercrime just tipped it. That's 2016. 450 billion, or $1,440,000 a second, or the same as buying 50 US nuclear carriers, the big ones. That's how much money was being made by the bad guys in 2016. So who thinks these numbers have gone down? Yeah. So 2022. Okay. Oh, I've lost my arrows. Okay, I apologize. Those squares are actually arrows. So 2022, 2016, 450 billion a year. 2022, $6 trillion a year. Right, and I think the bottom line puts it in more perspective. You used to be able to buy 50 nuclear-powered aircraft carriers. Now you can buy 620. Is that scary? Because this is what the bad guys are making. Let me put it another way. If cybercrime was a country, it would be the third biggest country by GDP in the world. That's how much money we're talking about. Do you think these guys are motivated? Yes. But it gets worse. It isn't just about money. Money is great, but now there's a new thing. So instead of all the old stuff, you still have botnets trying to get into your system, millions of botnets, millions of devices trying to get your system. People want to steal your secrets, steal your data, all that sorts of stuff. They want to do Bitcoin mining on your CPUs, all that still goes on, right? But now they want to hack into your open source projects. Why do they want to hack into your open source projects? Because you don't pay attention when you download stuff. And you download all the open source code without any checking, right? And they want to put malware wherever they can. They want to take control. And they don't want to do it to bring your attention, which maybe if it was ransomware, they want to bring it to your attention. That's the whole point. No, these guys want to do something else, right? There is this new term, and this term has been around for a long time, but it's crystallized. The last 18 months has shown this in action. So now we have bad guys who aren't trying. They would love your money, sure, but that's not what they want. Very professional, well-funded, large groups of people being funded by nation states to target people. And I do mean everyone. I mean, you are a specific target. As an individual, you can be a specific target. As a company, you can be a specific target. Just depends where you sit in the organization. But everybody wants a piece of this because it's so easy. Cybercrime has shown just how easy it is to penetrate systems. Right. Cybercrime, cyber warfare. I keep turning around, sorry. Okay, so let's move on. Let's talk a bit. Right. The reason this is important, the reason that we're here to talk to you about it is because there are things coming that will help prevent this. But you need to understand, I've said to you about downloads of dependencies and the scanning tools and how that's all a bit fragile. These guys are trying to get into that. It's your supply chain, right? Supply chain means the fact that you consume software, you publish software. And it might be your CI/CD system, it might be as a service, there's multiple things. But at the end of the day, it's part of a supply chain. And that's what they want to get into, because it's the connections between systems that are most valuable. So they want to get into pharmaceuticals, they want to get into banks, they want to get into schools, they want to get into railway systems, they want to get into lighting systems, anything, right? Get in there, not necessarily, definitely not visible, but not necessary to do anything immediately, because the object here is that when the time comes to affect that system, right? And this is from earlier this year? Yeah, earlier this year. You've seen this in action, right? You will have seen what was going in Ukraine. You will have heard about some of the cyber attacks that are going on. Everybody's doing this. This isn't, one or two countries. This is every country is aiming to do this. And the scary thing is now we're beginning to see evidence that this isn't just about attacking you potentially in the future. It's actually about attacking you now. It's about affecting your economy. Little tiny things can have massive effects. Get into your system. Maybe you're a shipping company. What happens if some bad guy comes in and screws up all the addresses? Well, it causes chaos. You fix it, but it happens again, or somebody else gets it. You can see small scale terrorist attacks that you don't really notice, that you put down to mistakes, impact your economy. And we're seeing that happen. Loads of money, loads of value, loads of capability, and it's out there now. This is real. As being part of Sonotype, because we have access to what the downloads are, and we have a good understanding of because our software is in a lot of companies, we get to see patterns. And supply chain attacks, of which there are various types, the numbers have just gone through the roof, right? 650% increase last year. You can bet that this year, when the numbers come out, it's not going to be any less. So this new thing is targeting the way that we produce software, right? And it's even worse, because we are used to at least having some notice that when a vulnerability comes out, that we have time to fix it. And that used to be called the 0 day. How long do you have? And it used to be 45 days way back in the distant past. Now it's gone. Vulnerabilities are being exploited before they're published. Log4j was around since 2014. There are other vulnerabilities out there that are being exploited right now that we don't know about, right? And they'll eventually get discovered, and when they get reported, you have to fix it instantly, right? And a lot of the time, they don't get reported. Some of the bigger ones are valuable themselves, so we have evidence of the people discovering these things then being paid large amounts of money to keep it suppressed. Okay? So, here's the net. Every piece of software in the world, wherever it is going to be a target for compromise. Every single piece of software, right? And whereas the bad guys used to go off and wait for these things to be reported, or maybe a bit of discovery, right? Now they make their own. Okay? They are targeting open source. They're going up the chain. They want to get into those open source projects that you consume. Right? And you can see the numbers. We already know that on average, there's always a certain number of packages on Maven Central that have high severity CVEs in them, right? But now they're going into the open source projects, right? They are trying to do social engineering to take over open source projects. They're trying to be good committers. They're doing whatever they can to get into the open source that you're consuming. So no longer do we have a situation where we're finding bugs that turn out to be nasty. We now have people actively trying to create those things, okay? And it's not just the source that you depend on, the dependencies. They're trying to get into the tooling. They're trying to get into the operating systems. They're trying to get into the firmware, right? Are you worried? Because I am, right? And I want to put this in context. So we have these bad guys that are doing all these, trying to do all these horrible things, and we as developers are downloading all this code without checking it and relying on scanning tools that may or may not be good enough to discover this. We need a much better way of doing this. We're sort of luckily, we have.
So that's a lot, right? And before we dive into what's looking, we have to think about it, how we can move all the plates that we have out there, because we like to juggle, and we have to pick one. Or do we have to do that? Or on the other side, we have to look at the full supply chain circle. And what we do, as we already know, we choose software that we aggregate to build new software, release it, operate it, and then the circle closes in. But we have to bear in mind a couple of points, like how do we manage supply chain, risk management, vulnerability, how we do that securely, and last but not least, to make the guys in suits that are smiling and looking at the licensing and the legal stuff happy, but also us. Because we have to consume it in a nice fashion. Luckily, we have a big brother that is watching sometimes on top of us, and Big Brother Joe signed the executive order last year in May, probably as a follow-up of all the details that Steve just mentioned, and decided to put his big eye in this supply chain circle, and he decided to put that in the form of the software bill of material. Like there are also in the case for other industries, like chemical industries, pharmaceutical, and so on and so forth. And he wants us to put a new label on our software. And that is unfortunately not a silver bullet, but definitely transparency will be the beginning of a more improved, proactive way of looking at defending our supply chain and the way how we build it. In short, this just gives us a bird's eye view of everything that is inside our code, not only the direct dependencies, but also the ones that are buried deeper. And if you want, you can just look at it as the ingredients on our food packages. And as it's the case with the food packaging, we can ignore it or do something with it. And in order to do that, the National Telecommunication Information Agency got the strict timeline of 6 months after the executive order was signed to come up with a couple of recommendations. Among those are approved formats, and we all know that we do like our battles, so before getting to standards, we have to be all across multiple versions, and currently there are 3 of them that are approved. The Software Package Data Exchange, or SPDX, that was initially thought about as license management, and it has probably the most formats out there. It's something for the guys that like JSON, and if there are guys that like YAML, of course, they can use that as well. The Cyclone Data Exchange comes from OWASP, while the previous one was coming from Linux Foundation. What all of them have in common is that they are machine readable, so they can be consumed in pipelines in an automated way, and they are open source. 2 of them, and the third one has a free guidance in order to be able to consume it and build it. And more than that, they do provide access to other databases through package URLs or software inheritance persistent IDs. Okay, but we do have these formats. What do they provide us? The other thing that came out of the workings of the NTIAs was to pick 7 fields that are available in each and every one of these formats, and they are interchangeable. We can just migrate from one to another, and this would provide us the information that we need in terms of who built the software, what versions it's out there, when it was built, and other unique identifiers, also as the dependency relationship with other points. So bringing all this together, we can get to the point where we can harden our software. And what does that actually mean? If we look at it, we have to have an SBOM that will provide us the mechanism, the information that we need to understand what's under the hood. On top of that, we need to have this in an automating fashion and provide also the proof of software integrity. So more or less that nobody got in the middle since we built it and we shipped it around. And of course, as we do like the bureaucratic things, we need to prove these aspects. We need to use to prove that the way how we consume third-party license packages, it's an appropriate one. And we do have a vulnerability disclosure program where we just raise the hand when something happens, and we are not proud of it. But yeah, as we do like to say, a picture is worth 1,000 words, and. Just yesterday, I suppose, I got my hands on this one, and it was the thing that I was missing in understanding everything. This nice tool that I think is still experimental. It's called the SBOM Doctor, and as we usually do with doctors, we do have an X-ray, but if we don't do what the doctor is saying, then it's not that nice. So here I took a snapshot of the Spring Boot web starter, and here in the corner you can see that there is a score. 500 is the top score that we can reach, and based on that we can see under the hood how many dependencies are here in the. So it's like an iceberg. We see just a bit of it, but under the surface there are a lot of other moving parts. And the other thing that the tool done for me is to provide me the answer that I usually look for when we need to pick a library. And always the answer starts with, it depends. What library do you use? And this one will provide us a better enforced way of getting into that. Okay, the question is, where do we put all the things? Well, they are bureaucratic, they are enforced on us, we know that we like to be enforced different things, chores. Of course, the pipeline. That's the heart and soul of our organization. It's the back end of everything, the backbone. And here we dump pretty much all the tools that can be automated on all the CLI tools. And regardless of the technologies that we use, we have a plain route, a plain traveling from the point when we write the code, push the commit, and up to the cloud. If you want code to cloud, as we will have farm to table. So we now have the information, or at least we have more information. What do we do with it currently? What are you doing at this moment of time, or what do you intend to do in the future? And I think it's the moment when we can have more conversation, right? Yes.
So we've already got one microphone. So you probably missed this because you saw the bomb doctor thing, and I will get the URL. But the thing to notice is it's complete. Can I go back? Right. So this is I'll say play tool, but it's a tool that we've been building. And this is, you can get SBOMs now off Maven Central, by the way, if you want to have a play. You probably missed the flip, but we went from you having scanning tools to tell you what you've got, and that's hit and miss, to moving to a situation where you've got actual real data that tells you what's installed. And that works on the basis that everybody in that pipeline, everybody in this thing, provides an SBOM, and actually it's more complicated because you get an SBOM and you get a digital signature and then you have to put it somewhere, but that's details. At the end of the day, what have you got? You've got proof of exactly what you've got installed And you don't have to have scanning tools to find that because you've now got it. And that means that if any of these have a vulnerability, you don't have to rely on your scanning tools to do this. You can take the SBOM to somewhere like this or wherever it's going to go and check instantly. Okay. Would that be a good thing? Yeah, because now you have certainty. That's good, isn't it? I like certainty, yeah. The other interesting thing, because I want to go back to this one too, because I think Olimpiu ran over this, I think some details here that you should think about. Read the words, evidence and automation. This isn't the SBOM. This is the other piece of consequences that you've got to deal with. So the SBOM is here now, but the consequences of the SBOM to you as a developer is to what happens to your infrastructure, what happens to your build processes when you have to start building and consuming these things. Just a little thing, if any of you feel like you like to sell your software to the US government, you've got about 2 years to get this sorted. And then after that, if you don't have an SBOM, then you can't sell software to the US government. Oh, the problem is that if you're at the top of this tree and you've got all these components, well, they need to have SBOMs too so that you can have one. So all your dependencies have got to have SBOMs. So in theory, we have 2 years or so to get every piece of open source to a state where we can have SBOMs. Obviously, it's not going to happen on those timescales, but you see where this is going. This is the beginning of the changes for all of us, and that the way that your process, where's that nice picture? The impact to this flow is going to be huge, because all those questions about evidence and accountability and applies to you as a business, but it applies in theory to every single open source project that we've got. And you think about how much effort we're asking small open source projects to do if they have to provide audit trails and evidence trails like that. That's not going to happen either. So there's going to be some tension out of this and some things are going to happen. But we have to do this because it literally is the only way for us to battle the bad guys, is to get a handle on what software we've got. We're not even talking about software quality, we're just talking about this really fundamental thing of managing the software that we use and dealing with situations where a known vulnerability is discovered. So you, on one hand, it's going to be good because you won't, as a developer, you may not have to do much more because the tooling will build up around you. But then as a developer, you may find that the way that you develop software is going to get a big stick applied to it, depending on where you are in this cycle. Okay, so there we are. I think that's it. I think you've heard why, and you've seen where it's going. It is early days. I mean, this is early days. Linux Foundation have got involved in this. Google's involved. IBM, Red Hat. There's a bunch of people talking this through, and something will fall out. But now is the time to keep your eye on the term of SBOMs, the terms of software supply chain, and just keep an eye out, because things are coming your way, and it's probably better to be forewarned than be surprised when one day somebody says, hey, that build system you've got, it's no longer required. You need to replace it with something else. Okay. Are we done? Yeah.
Yeah, pretty much.
Any questions? Yeah. Right. Okay. Run around for questions.
Okay, I would like to ask, for example, would an SBOM solution, if I have been applied 2 years before, would it have helped with Log4j? And what percentage of, because of course SBOM won't make all problems go away, what percentage of problems happening, issues, security breaches, would an SBOM, the SBOM solution solve?
Okay, so several questions, but the first one, let's talk about Log4j and SBOMs. The thing it would have dealt with was that all the scanning tools that people have now, which are not finding the Log4j vulnerability, would conceptually not occur because they would have an SBOM which told them exactly what they've got installed. It doesn't deal with the people who aren't scanning, but the tools that are not good enough to find the fact that there's a Log4j dependency, they would have dealt with that. So that would be the first one. The second thing is, I sort of like, where does this go? So currently SBOMs are for binaries, but there are going to be SBOMs. The idea is SBOM is a proof of the thing that you've got. And the next steps are going to be, it will fan out because it'll be an SBOM. It will be required to include information about how you built your software. So it'll say, what compiler did you use? And then what operating system did you run it on? I mean, that the ultimate goal is to be able to keep, is to be able to have a thing that can be used by somebody else to reproduce your build and prove that you have the same thing. Right. And there's another term, you'll hear a term called reproducible builds, which is another conversation. But basically, I hope I'm answering your question, but basically where this is going to evolve down to how was that software produced and where was it produced with enough information that somebody else could conceptually reproduce it and get exactly the same binary out of it. Right? And that gives you so much more power when you can be certain that the thing that you've just used compared to somebody else's go at building that is identical. You can be absolutely certain that the process has not been subverted because you can prove it yourself. Okay? Yeah. Others? Yeah.
Hi. I have two questions. First, how do we trust the SBOM? So,
good question.
So if I go to GitHub and there's an SBOM, is that enough? And the second question is related, I guess. We used to have things like Linux distributions. I mean, we still do, and they had. We trusted them. That they knew what was going into their package repos. Now it seems like no one cares about that anymore. Are we going to see that come back?
Yeah. Right. So the ones how do you trust an SBOM? Well, part of an SBOM is when you produce an SBOM, you have the option to create a digital signature for it, and you can then put the digital signature on a thing called a SIG store. Another term to go for is SIG store. So basically, yes, the proof, the signed proof that SBOM is that instance of an SBOM is valid will be published, and you can use your sort of keys. You can prove it, so you can access the public key and you can check that SBOM matches. But that's mostly good enough. But you always run the risk of, okay, what happens if the process gets subverted and the person publishing the SBOM and the signed key has have been corrupted? Well, that's possible. So there's two answers to that. One is that anybody can download an SBOM, right? If I give you a binary, then like a jar thing, people can create SBOMs. So there's some ability to recreate them. It's not perfect, but the other thing is reproducibility. So if you have if you take any random piece of source code and it has an SBOM, you should be able to rebuild that binary and do a binary diff. And the idea, right? We haven't got there, but the idea is that the only differences will be pre-described differences that says it is allowed for this field to be different because it's got a timestamp in it, or this field is different because it's got a vendor URL in. And that's the reproducible build thing. And we're at day one of that, but that's part of the thing as well. Is that good? Yes? Okay. Any more?
Hi. Couple of questions. One is if you know what's the situation regarding the SBOM in EU. Usually they follow up.
So it's
That's
currently it's coming down from the US. Everybody's expectation is that every government will follow suit because it is so essential. Yeah. Okay. Second question.
And the second one is regarding what you said about being reproducible, the binaries and such stuff.
Yeah.
There are many people are now using in open source as well the hash keys to compare when you download their binaries.
I'm sorry, I didn't quite catch that one.
Many people are providing hash keys that have been produced from their binaries in order to be able to compare. I mean, what's this, is that trustable? I mean, we've heard in discussions that, okay, there are many hash algorithms that have been broken.
So I think hash keys can go into the SBOM. You can put as much evidence in the SBOM as you want. SBOM's quite flexible. I'm not even sure if it's a standard, but that sort of thing is built in. Yeah. And so we were talking also about like Red Hat or Linux distros and Trust. They are going to have SBOMs. Everybody gets an SBOM because it gives you proof that this thing is correct. And as you say, hash codes and signatures and things will be used to validate. But the challenge isn't that we can't generate those, because we can generate those. The challenge is that we have to generate them for everything. And right now we're not doing everything, we're doing what we can, but it has to, by necessity, fold out. And I will predict that the way things are going, we're going to find that our build processes that we lovingly home grow are going to become more and more standardized and maybe even become commercial services. Because who remembers GDPR? We know when that came out, that put a load of effort on us to provide audit systems. I suspect we'll find that over time, the way that we build software will become more like cloud-based, more standard systems, because it'll just be easier. Yeah. Any more?
I don't think we have any more.
Cool.
So thank you so much for that very good talk.
Thank you.
And I'm sure people can send you more messages or questions through the app, or if you're around
Yeah,
in the hall
we're here
later
all,
on,
well,
please
I'm here all
hook
day.
up with them and pick their brains. Thank you so much.
Thank you.
All right.